Oh my god. Oh, we're finally on to the last one. Here we go. Look at the given. We're trying to prove that MP is congruent to NO. That means we're going to be using CPCTC once again, and that means we're going to have to prove that the two triangles are congruent. So let's take a look here. What do they give us? They give us that MN is parallel to PO, and that MP is parallel to NO. Oh boy. That means we're going to be using angle relationships to get anything out of this picture. So let's take a look at some angle relationships. Let's see if we can see anything here. I'm going to extend my parallel line. So I'm going to work with MN and OP first. Extend, boom. Extend, boom. And then my transversal, bam. And let's look at some angles here. Remember, it's got to be the angles in between the transversal and the lines. Right here and here. What are those? What are those? Those are alternate interior angles. Alternate interior angles. That means that they are congruent. So that's one angle, okay? Now let me erase my parallel lines. So we got one pair, we got one angle. Next, I'm going to extend the other pair of parallel lines. Boom, boom. Now what angle do we have here? It's going to be right here and right there. What are those? Those are also alternate interior angles. That means they're congruent. So now I've got two angles. I got angle and an angle. Angle and angle. And then we can see that in the middle they share this side. So that means we've got angle. Where's the angle? What's the angle? Side. Angle. Whoa, that means the two triangles are going to be congruent to each other by angle, side, angle. We had two pairs of alternate interior angles, and then we have a shared side that's going to be used on both. So now let's fill in our table. So we're going to have with step 1, MN is parallel to PO. I'm going to combine these. I'm not sure if this can take all the blanks or not, but I'm just going to combine them. MP is parallel to NO. Boom. That's going to be in the given. Next, what did we figure out? Let's label our angles that we figured out. So we had angle NMO. So angle NMO is congruent to angle. If it's over here, let's start down here. Look, POM. It's congruent to angle POM. Why? Alternate interior angles theorem. Next, all right, let's take a look at the side now. We got MO. MO is congruent to what? MO. What's that property called? Name that property. It's going to be the reflexive property. Okay. Label this ASA. Good. Okay, next, our other pair of angles is going to be angle, the pink angle, the one's labeled with a pink right here. Angle PMO. PMO is congruent to, if I start at P, went to M, and then O, I'm going to have to start at N, and then O, and then M. So NOM, angle NOM. PMO, and angle NOM. And that's going to be, once again, alternate interior angles theorem. Okay, that means I've got my look angle, side, angle. So now I can say my two triangles are congruent. So make sure you do it in the right order. So I'm just gonna use these ones right here. So I'm gonna use triangle PMO is congruent to triangle NOM. And why is that? By ASA, angle, side, angle. It looks like I could have split up my given into two blanks, but it really doesn't matter. Then last, we're gonna write the proof. MP is congruent to NO. How can we say that now that we've proved that the two triangles are congruent? By CPCTC. And we finished the review. We did it, guys. That means we're ready to get that great hundo on the test. Good luck, everybody, and I'll see you in the next time.